Hey everyone, today's lesson is on simplifying radicals or square roots. So your warm-up exercises just have you do a couple practice problems. I want to show you a couple properties when working with radicals. The first is the product property. And what it says is that when you have two numbers under a radical together, it's the same as having those two numbers under separate radicals multiplied. So for example, if I have radical 24, it's the same as radical 4 times radical 6, which I can then simplify into 2 radical 6. This works similarly with division, so we also have the quotient property. Which is going to be whenever you have a large radical a over b, it's the same as having radical a over radical b. And this is really helpful because you do not want to have radicals in your denominator, so we can work with that. So for example, radical 2 over 5 is the same as radical 2 over radical 25. And so I can simplify and say radical 2 over 5, because 5 is the square root of 25. A quick hint is to factor any numbers that are underneath the radical into perfect squares. So perfect squares, remember, are 4, 9, 16, 25, 36. And so we want to look at example 1 and pull out the perfect squares that we can. So the square root of 80 is the same as the square root of 4 times 20, or the square root of 16 times 5. 16 is an even larger perfect square, so I'm going to work with that and simplify that into 4 square root of 5. I pulled out that 16, did the square root, and multiplied by square root of 5. Square root of 6 times square root of 21, when I multiply those together, I get the square root of 126, and then I can factor out a perfect square, which is 9. 9 times 14 is 126. Simplified, 3 square root of 14. Letter C is similar. We are going to use the quotient rule. We can square square root of 4 and square root of 81 to get 2 over 9. Letter D is a little different because we can't find the square root of 7, so our numerator is going to stay the same. When we think about rationalizing a square root, what we're doing is we are avoiding the fact that we are going to have a square root in the denominator of a fraction. And so because we can use the quotient property and separate a whole fraction into two separate square roots, one over the other, we're going to use a magic 1, just like we would when we were simplifying fractions, and multiply the same square root over itself by our original fraction. So the example would be 3 over square root of 5. We're going to multiply by square root of 5 over square root of 5. And that's because the square roots multiplied together equal the whole number. So now my answer is 3 square root of 5 over just the number 5. By multiplying a square root by itself, you get the whole number without the square root. So you want to make sure that you are definitely 100% simplified when we're looking at radicals. And the way to check that is to make sure that there are no perfect squares left in the equation at any point. And also that there are no radicals in the denominator, no square roots in the denominator of any fractions. If those two things are true, then you're definitely simplified. Example 2 says simplify radical 5 over 2. So all we need to do is separate that into radical 5 over radical 2. And we do not want any radicals in the denominator, so we're going to multiply by radical 2 over 2, which is really just 1. And that's going to equal 2 in my denominator and radical 10 in my numerator. Simplifying letter B is a little more complicated because in order to get rid of the radical in the denominator, I need to multiply by the whole denominator, 7 plus square root of 2. And in order to do that correctly, when I multiply the numerators together, I have to use the distributive property. So 3 times 7 is 21, plus 3 times radical 2 is 3 radical 2, over, and then I have to FOIL the denominators together, right? I have two distinct sets of parentheses, so I actually have to FOIL those, simplify down, and I'm left with 21 plus 3 radical 2. And all of that is over 47 once we get down to simplifying. Example 3 says solve 3x squared plus 5 equals 41. I'm going to subtract 5 from both sides to start to isolate my x. So I get 3x squared equals 36. Divide both sides by 3. So I get x squared equals 36. I'm sorry, x squared equals 12. Take the square root of both sides, so x equals the square root of 12, or x equals 2 square root of 3. And we got that answer because 4 times 3 equals 12. Pull out the perfect square, which is 4, so that gets the square root of 2, and what we're left with is the radical of 3. So we're really breaking down these problems so that we can, the next problem we're going to solve is to write the solutions of the equation. That means they actually want us to solve for x. So I'm rewriting the example 1/5 times 2 plus 3 squared equals 7. I'm going to multiply each side by 5 to get rid of that 1/5 fraction. So I get 2 plus 3 squared equals 35. I take the square root of both sides, so I get z plus 3 equals square root of 35. And then I subtract 3 from both sides. So z equals -3 plus or minus the square root of 35. Square root of 35 doesn't have any perfect square factors, so we can't simplify that anymore, and that's our answer. Lastly, make sure you work on your daily homework quiz. We are going to skip example number 5, but we'll do that in class next time. These are just simplifying and solving the expression.